Welcome back. This is Polynomial Functions Part 2. This is the continuation of Thursday's lesson. We will continue discussing this on Monday in class as well. Okay. Today we're going to talk about how to find the zeros of a polynomial to sketch a graph, and then the intermediate value theorem. First of all, zeros of a polynomial function. The definition here says that for all polynomials, f of x equals ax to some power n, where n is the highest degree, there can be no more than n real zeros, and there can be no more than n minus 1 terms, or relative maximums and minimums. So that means if you have a 5th degree function, you can have up to 5 real zeros and up to 4 max and mins. Okay. Right below, these are all equivalent statements where they are used interchangeably. Okay. First of all, x equals a is a zero of f of x. X equals a is a solution of f of x. X equals a is a root of f of x. Those are all used very interchangeably. Even in class, we'll use them interchangeably. Typically, we use zeros or solution. If we say solve the equation, we're looking for the zeros. And then we have x minus a is a factor, and a comma 0, the ordered pair, is an x-intercept. But those are all the same thing because they all tell us where on a graph. If I've got some graph and I've got some kind of function like this, these are my zeros, those 3 points. Okay, they're zeros, they're solutions. If I do the opposite, think about vertex form, like when we shift x minus a, so it's the opposite, whatever that root is, those are my intercepts, and they are factors. And then down here, this is kind of important at the bottom. For any factor in the form of x minus a to the k power, where k is greater than or equal to 1, there will be a repeated root k times. Okay. Sometimes we call it a bounce because it does just that, it bounces. Important things to know: if k is even, the graph will touch the x-axis at that point, x equals a, so that's the bounce. And if k is odd, the graph will pass right through it. So what I mean by bounces, you guys have seen this before. Maybe you didn't know the terminology, but let's say I had 3 roots, here, here, and here. I just picked random points, and I've got some function goes up, down, and it looks like that. Okay, I have 3 roots. My end behavior is falls to the left and falls to the right, which means it has to be an even highest power. We talked about that on Thursday and Friday. And so we could have some even number of roots. Okay. If I look at this one crosses through, so that's an even power, or I'm sorry, that's an odd power for a solution. This touches and it bounces back up, so it's an even power, so that k would be like 2. And then this last one, same thing again, it crosses through, so it has to be odd. That might be a 1 or a 3, something like that. Okay, so I've got 3 solutions, but I know this one bounces, this one in the middle bounces, so this could potentially be an x to the 4th polynomial, because I really have 4 solutions here. This one right here in the middle just happens to be a double solution. Okay. All right. So finding the zeros. So to find the zeros, we just solve the equation. And something simple like this. So when we solve it, we're finding the x-intercepts. Remember, we're finding the places where my graph crosses the x-axis. Okay. So this graph could cross the x-axis up to 3 times, because we've got 3 possible solutions. So what I'm going to do is I'm going to set it equal to 0. 0 equals x cubed minus x squared minus 2x. And to solve this, the first thing I'm going to do is I'm going to try to factor it. And I see that these all have a common factor of 1x. So I'm going to pull that 1x out. So I have 0 equals x times x squared minus x minus 2. So this is one factor, this is the other factor, and I can factor this again and turn it into a product of two binomials. Because I know that I can multiply to -2 and add to -1. The two numbers that multiply to -2 and add to -1 are -2 and +1. So my other two factors are x plus 1, x minus 2. So I've got three factors: x minus 1, and x plus 1 and x minus 2. And now to finish solving that, all I have to do is set each factor equal to 0. X equals 0, x plus 1 equals 0, and x minus 2 equals 0. And when I solve those, I get x equals 0, I get x equals -1, and x equals +2. So these are my three solutions, or my three roots, and they're also my three x-intercepts: 0, 0, -1, 0, and +2, 0. So those are my three solutions. They're my three roots. They're my three x-intercepts. And up above, these were my three factors that got those. Alright, what if I want to find the zeros, but this time I have a more difficult problem and there isn't a common factor between those? Well, we can always use our friend the calculator to do that. So I'm going to go over to my calculator screen, and I'm going to put in that function, which was x to the 5th power minus 3x to the 3rd minus x squared minus 4x minus 1. Okay. And there is my graph. Now I can't see the bottom of the graph, but I can't see anything below this point, but that's okay. I don't really need it. All I need to know are the three places where it crosses the x-intercepts, or where it crosses the x-axis. I can see it crosses here, here, and here. So I'm going to use my graph to find those points. I'm going to go to Menu, Analyze Graph, 0, that first one, and I'm going to move my hand to the low side of the first one, and then I'm going to move it back over until I get just past that first 0, and there it is. So my first 0 is at -1.86, comma 0. I'm going to follow that same process again. Go to the left side, go to the right side. There's my second 0, which is at -0.2540. And then I'm going to do that for the third one. A little bit left, a little bit right, and there's my third 0. So I've got three solutions. And I'm going to put those in our slide so we can see them. And there they are. Okay. So we can see our three solutions, and we did it all by graphing. Alright, next I want to sketch the graph of 3x to the 4th minus 4x cubed. So I'm going to start by looking at my power. I know it's the 4th power, so my end behavior is going to be up on both sides. Okay, remember that from Thursday and Friday. Rises to the left and right, so it's going to look something like an upward facing parabola. Okay, but I want to make it more specific. I want to find my zeros, plot those zeros, and then plot a few extra points in between those zeros so I can see what happens. So I'm going to start with solving it. 0 equals 3x to the 4th minus 4x cubed. I'm going to factor out that x cubed. So I've got 3x minus 4. This is going to be a repeated root 3 times of x equals 0. And the 3x minus 4 equals 0. We'll solve that to get x equals positive 4/3. So I've got an ordered pair 0, 0, another ordered pair 4/3, 0. So I've got 2 points I can plot, but I want to get a couple more. Okay. So what I'm going to do is make a table of values, and I'm going to pick in between 0, 0 and 4/3, 0. I'm going to pick the point 1/2. I'm going to pick the point 1 for x, and I'm going to plug those two values into my original function. And when we do that, we get negative 5/16 and negative 1. So I've got now 4 points I can graph. I've got this guy, one x-intercept, a second x-intercept, and this 0, 0 x-intercept was a repeated root, but it was repeated 3 times. So if you go back in your notes and you look at a couple of slides before, I said that if it's repeated an odd amount of times, it just passes through. Okay, so now I can graph this. So I know I'm going to plot a point at 0, 0. I'm going to plot another point at 4/3, 0, which is going to be about right there. Okay, this should be a little bit more to the left. That's okay though. And then I'm going to plot this negative 1/2 and negative 5/16. That's going to be about right there. And 1, negative 1 is right there. Okay. So when I graph this now, or when I finish the sketch, I get something that starts high on the left, comes down, passes through that point, kind of squishes in, comes down some more, and then back up. And we get a little bit more accurate graph than what we started with, which was just said, I know it went high to the left, high to the right, and it looked like that. But now I've got a better idea because I graphed the roots and a couple points in between. Okay. So next, we are going to write a polynomial function given some information. So the information we're given is we're given 3 zeros, negative 1/2, 3, and 3. So we have a repeated root. So I want to write a polynomial function. If I have 3 zeros, the smallest polynomial I could possibly have would be something in the form of y equals x cubed. So I have 3 solutions. I have to have a polynomial of degree 3 or higher. Well, if we go back again and we look at what a solution means, it means that I have x minus 3, x minus 3, and then x plus 1/2 as my 3 solutions, or as my 3 factors that gave me those solutions. So now all I have to do is do some multiplication, FOIL some stuff out. This becomes x squared minus 6x plus 9. And I'm going to multiply that by x plus 1/2. Then when I factor that, I'm going to get x cubed minus 1/2 x squared minus 6x squared minus 3x plus 9x plus 9/2. When I simplify that, x cubed minus 11/2 x squared plus 6x plus 9/2, and that's my function. And that's it. We're done.